Question number 9 from November 2020, HL paper 1. We need to use the substitution x is equal to tan u to find the value of this definite integral. So to start, firstly, we can find the derivative of x. So the derivative of x with respect to u is equal to, now the derivative of tan is secant squared. So this will be secant squared u. From here I can solve for dx. So dx will equal secant squared u du. Now since we are making a substitution, we also need to change the limits. So when x is equal to 0, we have tan of u is equal to 0. So u is equal to 0 because tan of 0 is 0. And similarly, when x is equal to 1, we have tan of u is equal to 1. So u is equal to pi over 4. Now if you're not sure how to get this, you can use the one of the magic triangles, where this angle is pi on 4. This is also pi over 4. This is 90 degrees. This is 1, this side length is 1, and this side length is root 2. So tan of pi on 4 will be 1 upon 1, which is just 1. So we find u is equal to pi on 4. Now we are ready to make the substitution. So this will give us the integral from 0 to pi on 4. And I can replace x squared with tan squared u. So tan squared u upon 1 plus tan squared u to the power of 3, and I can replace dx with secant squared u du. Secant squared u du. Now to simplify the denominator, I can use this identity where 1 plus tan squared theta is equal to secant squared theta. So we'll be left with the integral of from 0 to pi on 4 of tan squared u divided by secant squared u to the power of 3 secant squared u du. Now this expression will simplify to secant to the power of 6u, and since we also have secant to the power of 2u, this will simplify to secant to the power of 4u. So we'll be left with the integral from 0 to pi on 4 of tan squared u upon secant to the power of 4u du. Now to integrate this, what we can do is we can simplify this expression. So to simplify this, we need to convert each of these in terms of sine and cos. So tan theta is equal to sine theta upon cos theta. So tan squared u will equal sine squared u upon cos squared u upon. Now secant is the reciprocal of cosine. So secant to the power of 4u will equal 1 upon cos 4u. So we can, if we divide this, this will give us sine squared u upon cos squared u times cos to the power of 4u, and this simplifies to sine squared u times cos squared u, which is equal to sine u cos of u whole squared. Now using the double angle identity for sine 2 theta is equal to 2 cos theta sine theta. This will be sine of 2u is equal to 2 sine u cos u. So if I bring this 2 to the left hand side, this will give us this expression, sine 2u upon 2 is equal to sine u cos u. So if I square both sides of this expression, this will give us sine u cos u whole squared is equal to sine 2u upon 2 whole squared. So this integral is simplified to the integral of 0 to pi on 4 of tan, this is now simplified to sine 2u upon 2 whole squared du. Now 2 squared, now I'll write this, so integral of 0 to pi on 4 Now if I square this, this will be sine squared 2u upon 4 du, and I can bring this constant in the front of the integral. This will be 1 upon 4 integral from 0 to pi on 4 of sine squared 2u du. Now I can use the double angle identity for cos, one of them, to simplify sine squared 2u. So we know that cos 4u is equal to 1 minus 2 sine squared 2u. So if I solve for sine squared 2u, this will give us sine squared 2u is equal to 1 upon 2 minus cos 4u upon 2. So I can replace sine squared 2u with 1 upon 2 minus cos 4u. So this will give us the integral from 0 to pi on 4 of 1 upon 2 minus cos 4u upon 2 du. Now from here, the integral of 1 upon 2 will be 1 upon 2 times u, so 1 upon 2 u minus, and the integral of cos is sine, so sine 4u upon 2, and we also need to divide with the derivative of 4u, so this will be 1 upon 4, and then we have a limits from 0 to pi over 4. And now we can directly substitute these limits into our expression because we already changed the limits in this step. So if I substitute the limits, this will be 1 upon 4, 1 upon 2 times pi over 4 minus 1 upon 4 sine. Now 4 times pi over 4 will just be pi, so sine of pi upon 2, and this will be subtracted from 1 upon 2 times 0 minus 1 upon 4 sine. Now 4 times 0 will just be 0, so sine 0 upon 2. Now from here, this will be this 1 upon 2 times pi over 4 is pi over 8, and sine of pi is 0 from our understanding of the unit circle, so this will be minus 0, so we don't need to consider this. And also notice that 1 upon 2 times 0, this is 0, and we have minus. Now sine of 0 is again 0, so we have 0 minus 0, so again this entire thing is equal to 0, so we don't need to consider this, so we'll just be left with this 1 upon 4 times pi over 8, and this is equal to pi over 32. So this is the value of this definite integral, and this is the answer to question number 9.